Alright, so today we are going to talk about structures. Okay, so that's what we're going to talk about today. So what do you understand by a structure? Actually, you know that whenever we are to use a variable, we need to declare the data type of that variable, isn't it? For instance, if we want to use the variable a and we want to store an integer value inside that variable, so all we need to do first is to define the data type that that variable is going to hold. So we need to pass in int and then the variable name a, right? So we can either initialize the variable at that same line, or we can move on inside our code somewhere and we can initialize it with the value 10. So what we know is that this variable, whenever you declare it as an integer, it is only going to store integer values, isn't it? If you declare it as a float, it's going to store only floating values. If you declare it as a character, it's going to store only character values. So you cannot mix up characters and float inside the variable. Just like arrays, when you declare an array of type int, you can only store integer values in that array. You cannot store floating values in an array that is declared as an integer. You know it's not possible. So in arrays, you cannot deal with information that has different data types. You can only deal with information that have the same data type. Take for instance now, let's say you are a teacher, for instance, and you have like 20 students in your class. So, and you want to create a record of those 20 students. So you know that each of these students has name, which is of type character, isn't it? They have their age, right? They also have what let's say the scores. The age is an integer, right? Let's say consider the age as an integer. So, and also let's say they have their score, right? You need to store their score. So the score can be in float, right? So as you can see here, you need to what? You need a variable of what data type? Of a data type that will be able to store characters. The data type should be able to store, the variable should store character, the variable should be able to store float, the variable should be able to store int. So as you can see here, you are dealing with what? 3 different data types, assuming you don't have any knowledge on structures. So if you are to do this, you know that you are going to create an array to store what? For each student, you will create an array to store the name of the student, create another array to store the age of the student, create another array to store the score of the student, isn't it? That's what you're going to do. Had it mean you don't have any knowledge of structure. So for each student, it's like you are going to need 3 variables, isn't it? That for the age, that for the name, and that for the what? Age, for the score. So if you have 20 students, it means you are going to create 20 times 3 variables, isn't it? Which is 60, right? You are going to create 60 variables for all the 20 students. So don't you think this is going to be stressful? Of course it is going to be stressful. Why the need of creating a lot of data types? Why will you be a lot of variables? Each student will take 3 variables. So, and all what we are after is whenever you are to write a clean and efficient code, you have to find the possible shortest means of what? Solving the problem. So this is where structures come into play. In structures, you as the person writing the program, or the person that want to store a record, you can define what type of data types you want to store in your variable. So structure is a variable itself. It's a data type itself. But it is what? It is a user-defined data type. You are the one who defined what the data type should hold. Do you get it? Is the data type going to hold an integer? Is it going to hold a float? Is it going to hold a character? You are the one to define that. So structure is simply a user-defined data type. That is just what a structure is. Okay, so we are going to explain some things before we begin solving example on structure, so that we get to understand more about what structures is. All right, so what I was saying initially, you know that when you are to declare a variable, we do something like this, a, right? And this will what? The computer will allocate what? 4 bytes of memory to store this variable a. We know that int holds what? 4 bytes, right? That's what happened. So if you do something like this now, int a, and you say 60 now, this is an array, right? So the computer is going to allocate what? 60 times 4 right? 4 integer is 4 and you're storing 60 word data. So 60 times 4, the computer will allocate that amount of space for you in byte, right? So, and you know that here you cannot store a character inside this variable a because it is already declared as an array that will hold what? That will hold only integer values, isn't it? So you cannot store character inside. So like I was saying, if you have a student, each of these students, you need to know the name of the student, the score of the student, and the age of the student. So for you to do this, let's assume the age, right, is of type int. Or let me do something like this. Let's say the age is of type int, so I can simply say int age, right? And then I'll pass in the size here, right? Also the name, int name, and then I'll pass in the size here. Also the score, sorry, the name should be car, yeah, sorry, it's a character. So also the score should be a float, it can be in decimal, right? So I will not say score here, and here you need to pass the size. So this is what you need to store one student's data. So if you have 20 students, like I said, each of these students needs to have this variable declared specifically for them. So to avoid this is where structures come into play. And in structure, you define the data type yourself. Now, how do we declare a structure? The first thing you need to do when declaring a structure is to pass the keyword struct. This is the keyword struct. This tells the compiler that this is a structure. So the next thing is you need to give the name of your structure. Let's say my own is, let's say students, right? So I can just say student here. So now I've declared a structure called student, right? So I need to tell the structure what are the data types I want it to store. So the next thing is, we know that in the student I said I want to store what? Integer, right? Of what is what variable is going to store the integer? The age, yeah. So age is going to store this. And we know that we have what? The character, right? Isn't it? The character, this is going to store what? The name. And the next thing we have is what? Is the score, which is the float. Right? So this is it. Now we have declared a structure. So whenever you do something like this, don't forget at the end, after the closing curly brace, you need to add a semicolon. So this structure here now, like I said, structure is a data type. The whole of this now is the data type. Do you get? The whole of this is the data type. So let's say I want to store for student 1. What I need to do is I will just pass in this struct student as the data type, and then I will pass S1. For instance, I can just say struct student. So now this is the data type, and then I will pass in S1. So now this S1 here, what is the data type of S1 is struct student. It's just like saying int. Alright, so I was saying here, now this is what the data type, struct student. Okay, so whenever you declare a variable, so now let's say you know that when we do something like this int and we say S1, we are only going to store integer value inside S1, and the data type of S1 is what is int, right? So same applies to this here. This is S1 here, and what is the data type of S1? Struct student. So it means this variable S1 here can store integer, can store character, can store float, because the data type is what is struct student, and this is what struct student. Do you get it? So now this S1 can be able to store information of different data types, and that is why we need structures. Do you get it? That's why we need structures. We need structures to store information of different data types. Alright, so now after creating a structure, how do we declare a variable now? We have a structure. I think the best way is, let me do this on the terminal. I think it should be better. VI, let me create a test file to explain concept. Hash include. Sorry, I'm explaining concept. So stdio.h. So int min, and then void. All right. So now, how do we declare these structures? We said we declare structure by saying struct, like this, right? And then the structure name, let's say student, isn't it? And then here we need to define the data type that the structure is going to hold. We said int, which is going to store the age, right? We also say char, but since we are storing characters, we know that when we're trying to store variables that host character, we need a pointer. So it's a pointer to a character name, and then what again? And then we need to store float of what? That's the score, right? So here we need to close it with a semicolon. So now I have a structure defined. This is how we declare a structure, right? This is the structure, and this is what the members of the structure. It's called the members. This is the members of the structure. So like I said, let's say we want to declare a variable of what? Struct student data type. All we need to do is add the what? The variable name. Let's say we have 5 students, or let's say 3 students, right? Let me just call them st1 comma st2, for instance, just 2 students. So you can declare your variables here, that is before the closing semicolon, or you can simply come outside the structure and then declare the variable. So to declare the variable, you need to pass in the data type. We know that before we declare variables, we pass data type first, right? So you need to pass in the data type struct student, and also if you have another student, you need to pass in and then what? The structure, the variable name st2. So these variables here, st1 can store integer, it can store character, it can store float. Do you get it? So this is what? Declaration. So one thing you need to know about structure is that you cannot initialize any variable inside the structure. I cannot say equals to 10 here. You cannot do that. Also, you cannot create a member with the same name. I cannot come here and declare another variable and say float age. I already have age here. So I cannot declare another name or another member of what? Of age. Do you get it? I cannot do that. So this is one thing you need to know. So this is simply how to declare a structure, right? And this is what? How to declare a variable using the structure data type. So the first thing you need to do is pass in the data type, which is struct student, and then what? And then the variable name. Do you get it? So what of initialization now? Now I have st1 and st2 declared. Let's say I want to store the record for this student. How do I store the records? How do I store records of this student? I can simply say is equals to, here I can do the initialization, and then I will open a curly brace. So what is the first thing that the struct student is supposed to hold? It's supposed to hold the age, right? You need to take note of the order in which they are stored. So the first thing you need to pass to the variable is the age first. So let's say I pass in 20. And the next thing is what? Is name. Right? So what is the name we need to use? Let me just use John, for instance. You know that we are dealing with strings, so we need to pass it in what? Double quotes. Right? So the next thing is what? Is the score. And the score is a float. Right? So let's say 12.5. So now I have the information for the first student stored. I didn't mean now I don't have a structure. I didn't mean I don't have a structure. You know, I need to declare a variable for 20. I need to declare a variable for John. I need to declare this. So this has saved me 2 variables. Isn't it? Same applies to the st2, the second student now. I need to pass in what? What is the age? Let's say 15. So let's say, let me use James here. And then what's the age? 10.5. Sorry, the score is 10.5. So now I have initialized them. Isn't it? I have initialized the record for each of the students. So let's say I want to print the score of st2 now. How can I address the score, which is this? How can I do that? I can simply say printf. I'm printing the score, and the score is a float, right? So %f in a new line. So how do I target this here? So to target this, what is the variable that I'm targeting? I'm targeting st2, right? That's student 2. So I need to pass in st2 here. I'm targeting student 2. And what member of the student am I targeting? I'm targeting the score of that student, right? So I will now say dot score here. So this is going to print the score for me. Let's test this program. So gcc test.c -o, let me call it t. Yeah, so it's compiled. So let's run this. So did you see that we got 10.5 printed, but because float %f print what in 6 decimal places, that's why we see the remaining fields filled with what, the value 0. So this is how you can target any member. Let's say now I want to target the name of what, of this first student. So all I need to do here is change this to name, and then this to what, 1. I'm targeting that of the first student, and then this should be what, S, since I'm printing a string. So I will compile, run. So did you see that I got John, right? I got John. So as you can see, structures are very important when it comes to storing information of different data types. As you can see here, with just one data type declaration here, I'm able to store information of 3 different data types without any problem. So this is just one good thing about structures. Okay, so this is one way of initialization. Now there is another way of initialization. I can do something like this. Now instead of declaring it here or initializing here, I can say I can use what is called the dot operator, or it's called the member operator, just like what I did here, st1 name here. So all I need to do here, I can just say st1 dot name, right? I'm sorry, yeah, in this case it doesn't matter the order. Okay, in this case, if you are doing to use this method to store, it doesn't matter the order you use to follow to store it. If you like, start from the last element, it doesn't matter. Okay, because you have already targeted the member in which you want to make the changes to. So let me make use of the same John here. Now I have this, right? So I can now say st1 for what, let's say for age. I want to store the age now. So what is the age? Let's say 12, and then I will need to target what, st1 the score, right? So the score is let's say 10.5. So I can initialize like this. So let's try printing the st1 name, which is the name of the word of the first student, right? I'm expecting this to print John. So let's see. Okay, what happened? Okay, I used I used this, yeah, a string. Yeah, so let's compile. All right, so let's run this. So did you see that I still got John?
Yeah.
So you can initialize either using that the curly brace, but if you are initializing using the curly brace, you need to take note of the order. You need to store the information based on the order that is what, inside the structure. Do you get it? So this is simply initializing a structure. This is how you initialize a structure. So we know that a data type int has, what is the size of an int? The size of an int is 4. So since this is also a data type, it also has its own size. So what do you think the size of this structure, student, is? Yes, it will be the int. What is int? 4 plus character to a pointer 8 plus float 4. So that's going to be the size of this struct student. You can use printf size of to get the size. Okay, it's just a normal data type here. So I think this is all we need to know about structures. Or before that, let me explain the last concept of structure, which is known as the typedef structure. Sorry, the typedef keyword. So the typedef is used to give you your structure an alias. You need to give it another name. So instead of always calling struct student whenever you are trying to target that same structure, you can save all this lengthy code here, or let's say this lengthy text here. You can just give it a short name. So here, to give my structure another name, I can just use the typedef here. Just type in typedef here, struct student, and here before the semicolon, you give it the name. So let's say, let me just call it student instead. So here, whenever I want to target this struct student, I can just call the name student. That's all. So here, instead of me adding struct student, I can remove the struct now. Yeah, I can just remove the struct now. So let's see if this will work. So did you see that it still worked? Right? So this is all we need to know about structures. So if there is anything we need to know, maybe if you begin solving an example, we'll be able to address that. So let's move on. So make sure you go through the materials, okay? You'll understand more about structures, okay? All right, so let's begin solving examples. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to bitweblearn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX Complete C Programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, more nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also, if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor because I've already registered. That's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. This is task 0. It says define a new type struct doc with the following elements. So this is just asking us to declare a what? A structure. Okay, so I'll just say vi dog.h. So one of the importance of a header file is not just to write prototypes or macros, it is also used to add structures. So far we've seen 3 uses of the header file, right? The first one is to add function prototypes. The second one, we said it is used to define macros, right? We define our preprocessor macros there. And also the third one here is what? Is structures. Okay, so now the first thing we need to do is we need to guide it, right? So hash if not def, and this is dog underscore h, right? And then hash define, right? Also dog underscore h, and then hash and if, right? So how do we declare structure? So this is the structure name, right? Struct dog. So I'll just copy this and paste. All right, so here I'll just open these 2 brackets. So it says what? These are the members, right? The element. We should have name of type of a pointer to a character, right? So I'll just say car asterisk, and I'll just say name, right? So the next one is what? The next one is age, which is of type what? Float, right? So I just say float and then age. So the next one is what? Is owner of type pointer to character, right? So I just say car asterisk, and I'll just say owner. I think that's all right. So here we need to add the semicolon at the end. All right, so that's all we need about this. So let's save and exit. So let's run Betty. We need to run Betty on our dog.h as well. So as you can see, I've not explained anything about that, right? So I need to do the explanation here. So here, I think that's all right. So let's run Betty again. So as you can see, Betty is happy with this, right? So the next thing we need to do is to copy the test file. Copy, and we need to create the test file 0main.c. So paste this. All right, so let's compile now and let's see if we will get the exact output. So copy, paste. All right, good, compiled. So let's run it. So did you see that we got my name is Poppy, I am 35. Woof, just look at this. Okay, so here they gave it a name which is called my dog. So here they are pointing to my dog. My dog.name Poppy, my dog.h 3.5, my dog.owner Bob. So that's why when they printed all the content of each members, we got this printed. Okay, so that's simply how to do this. So this task here says we should write a function that initializes a variable of type struct dog. Okay, so now we are to initialize the variable. Now we've already declared the variable struct dog, right, from task 0. So now we need to initialize it. Okay, so now first let me copy the function prototype. I need to take it to my dog.h, right? So it has to be here. So I'll paste it, right? So I have the prototype now. So let's open the file, this vi paste. All right, so you can see I already have my Betty documented. It says we are to initialize a variable of type struct dog, and this struct dog has been created already, right? We've already declared struct dog from task 0. So I've already showed you in the introductory part of this particular project on structures how to target each member of a structure, right? So that's what we're going to use here. Okay, so here the first thing we need to do here is this. So this D here, right, this D here is the new variable that we need to initialize with what? The name of the dog, the age of the dog, and the owner. Because when you look at the struct dog is not the data type of what? Of the variable. So it means this variable now can store what? The name of a struct of a dog, the age of the dog, and the name of the owner. Isn't it? Because struct dog, when we declare it, it can store what? Name, age, and owner. Don't forget, from task 0. So the first I need to do here is I need to check, right, if the D, that is this, the variable, right, D here, if it is not a null. So I'll just say if D is not equals to null. So if D is equals to null, then I can do the initialization. Okay, so if D is not equals to null, what should I do? The first thing I need to do here is this. I need to point to the name, right? Don't forget struct dog here, right, is storing name, age, and owner, right? So the name that will be passed to this function is going to be attached to the name of the struct dog. Age is going to be attached to the age of struct dog, and owner is going to be attached to the owner of struct dog, right? So now what I'm going to say is, since D here is pointing to what? To struct dog, so I'll just say D and what? Name here. I've already explained this in the introductory part of this project, right? So this is how we access the members of a structure. So D name is equals to what? Is equals to name. So what this means is that whatever the name that is passed here will be associated with what? Struct dog and what? Member. Struct dog and what? The name member. So it means that whatever the name that is passed to this function as the second parameter will be what? Attached to the name of struct dog. So the next thing is what? Is the age, right? So this is going to be what? D age is equals to what? Age as well. So I'm initializing age with the value age. Whatever age is passed to the function will be initialized here, right? So the next thing is what? Is the owner. So D owner, right? So it's equals to what? It's equals to owner. So that's all. So that's simply the initialization. Okay, so let's run Betty on this. So Betty, okay, Betty is fine. So let's create the test file, vi1 main.c, right? So let's copy test file, copy and paste. All right, so let's compile. So this and copy paste. Okay, it says D is equals to null. Okay, I need to include the library for the null. So it is in what? Hash include stdio.h, right? Okay, yeah. All right, so let's run it again. All right, so as you can see, it has been compiled. So let's run the compiled file. So did you see that I got my name is Poppy and I am 3.5? Oof. Okay, so this is the exact output here. Do you get it? It is the exact output. So don't forget to add, commit, and push to a GitHub, and then you can run your checks. So let's move on to the next task. So this task here says we should write a function that print a struct dog. Okay, so this is the prototype here, and format see example below. You are allowed to use the standard library. If an element of D is null, print nil instead of this element. If name is null, print name nil. If D is null, print nothing. Okay, so let me copy the function prototype first. Let's take it to our dog.h. Right, so here this is going to be here, right? So pastes. All right, so now we have the prototype. So the next thing we need to do is to open the file, which is this. So vi pastes. So as you can see from here, I already have my Betty documented to avoid time wastage. So what's the first thing we need to do here? We need to check if our D is not null. Okay, this is the pointer to the struct dog, right? As you can see, the data type here is struct dog, isn't it? So this is pointing to where we need to what? Print from, isn't it? And the data type is what? Is struct dog. So first we need to check, is D a null byte? So I'll just say if D is not equals to null, sorry, I said null byte. If D is not equals to null, that is when we want to do something, right? So what's the first thing we need to do here? It says that if an element of D is null, we should what? Print nil instead of this element. Let's just look at the output here. So did you see what happened? It first prints name and then it prints the name, age and then the age, owner and then the name of the owner, right? So what do we need to do here? What I need to do here is simply say printf, right? The first thing I need to print is the name, right? Just look at this, is the name. So I'll just say name, isn't it? And then what? I'll pass in the placeholder, which is %s, right? So pass in the name. All right. So what am I going to print here? I only want to print what? Name if it is not a null, right? So I can pass in this. I can say D name. We know that the name is stored inside this D and also this member here, D name, right? The name is stored here. So, and the condition is if D name is not equals to null, right? That is when we want to print it. So I can simply use the ternary operator. So I can just do something like this, and then here I will just pass in name, and then I will pass in bracket, I will pass in nil. So what does this mean? This is a ternary operator I used. So what this is going to do is this. It will check if D name is not equals to null. If it is not equals to null, it will print the name. Okay, after this question mark here, the conditions will follow. So this will only execute if this is true. So if D name is not equals to null, then it will print the name. This semicolon, full colon here means else it will print nil. Do you get? That's what the question says here. Else we should print the name and then nil. Print name and then print nil. So that's it, name here and then nil. So if D name is not equals to null, print the name, else print nil. That's ternary operator. Okay, so the next thing we need to do is print for age. So I'll just say printf, that is age, and age is a float, right? And as you can see here, it has not been, okay, it is in 6 decimal place, so definitely we are going to leave it as %f, right? And then we pass in /n. So same as this, I'll target what? The age, right? D age. So if the condition is not null, what should happen? We are to print the age, isn't it? Else, what are we going to print? So since this is an age, we don't have nil. We cannot use nil or something like this. So it has to be 0. This is what is representing age, float or integer. Okay, because it is a float, that's why I use 0. You cannot use nil here. If you try to compile with nil here, you will get an error. Okay, so the next thing is what? For the owner. So printf, this is what? Owner, right? Owner. And then this is %s /n, and then D, right? In this case is what? Owner, right? And then if owner is not equals to null, we should print what? We should print the owner, isn't it? The owner. Else we are going to print what? Nil. Else print nil. That's all. That's just what this is asking us to do. Okay, I believe this is clear, right? So let's run Betty on the file. So Betty, good. So it has been compiled. So let's copy. Sorry, Betty is happy. Let's copy the test file. So vi to main.c. All right. So paste. All right. So let's run the compiled file. Sorry, let's compile the file. Copy and paste. All right, so it has been compiled. So let's run it. So did you see that I got the age Poppy, the name Poppy, the age 3.5000, the owner Bob, just like this. Okay, the same output here. So it means that our function here is working the way it's supposed to work. Okay, we've printed everything that is set inside the struct dog. So look at this, my dog.name is set to Poppy, the age is 3.5, the owner is Bob. So all what we did is just print from this, right? Print from the struct dog. That's what we did here, and as you can see, we got the exact output. So don't forget to add, commit, and push to your GitHub, and then you can run your checks. All right, so let's move on to the next task. So this task here says we should define a new type dog_t as a new member for the type struct dog. This is a very simple project. We are just going to use typedef in this case. So this is just simply asking us to give our struct dog structure a new name called dog_t. Okay, it says define a new type dog underscore t as new name for this struct dog. So this struct dog now is going to take new name. And how do we do that? I've already explained this in the introductory part of this video. We use what? Typedef. So that is how we give our structure another name. So you simply type in typedef, and here after the semicolon, sorry, before the semicolon, you give a space and then you type in the new name. So in our own case, it's what? Dog underscore t. So dog underscore t will now be representing struct dog. Anywhere you call dog underscore t, it's like you're calling what? Struct dog. Okay, so now let's exit. So let's run Betty on the dog.h to ensure everything is fine. Yeah, everything is fine. So let's create the test file as well for this. So 3 vi 3 main.c main.c, right? All right, so pastes. All right, so let's compile. GCC, copy this and paste. All right, compile. So let's run the compiled file. So did you see that we got the exact same output? Did you see here dog underscore t is the new name for our struct dog, right? So they call the dog underscore t and they pass in their own name, my dog. So it means that if this was not passed, this my dog will not be able to be called. Okay, so as you can see, we are getting the exact output here. So don't forget to add commit and push to a GitHub, and then you can run your checks. So we're going to stop here. In the next video, we are going to continue from task 4 of this project. So thank you very much till we meet in our next session.